Welcome to lesson 3.2. Let's look at some more identities for trig. Now we've got all of the double angle identities up here. We have sine of 2 theta equals 2 sine cosine. Notice we have 3 different versions for cosine of 2 theta, and we'll do an example in just a second to show that you can use any of those versions to get to the same answer. Then we also have tangent of 2 theta. Yes, you do have to memorize all of these. They will be on your memory test. So understanding that, let's try an example where we use them. Let's suppose we have a point that is on the terminal side of theta. So this point is negative 3, 4. There's my point. And I know it's on the terminal side of theta, so there's my initial side. There's my terminal side. There's my theta. We want to find cosine of 2 theta and sine of 2 theta. So, first off, I'm going to make a right triangle, just like I normally do. I'm going to label this side negative 3 and this side 4. And let's do Pythagorean's theorem real quick to find that last hypotenuse. We do a squared plus b squared equals c squared. So we have c is plus or minus 5. Because this is the hypotenuse, we know it's positive. It's a radius of a circle, makes it positive. So I have this full thing right here, this full triangle all labeled out. And we're going to start by finding cosine of 2 theta. So essentially we're saying if I double this angle, where is it going to end up? So right here, there we go. Here's my theta. If I double that, where is the point going to end up? If I take this angle and I double it, where exactly does my point finish? So with that in mind, we have 3 different cosine of 2 theta equations that we can use. Oh, not that. We have cosine of theta whole thing squared minus sine of theta whole thing squared, aka cosine squared of theta minus sine squared of theta. We have 2 cosine of theta squared minus 1, and we have 1 minus 2 sine of theta squared. So I'm going to go on this triangle and find out what sine of theta and cosine of theta are. We can use that using either definition, x over r or SOHCAHTOA. So sine of theta I know is y over r, or opposite over hypotenuse, which on this triangle would be 4/5. Cosine of theta is x over r, or adjacent over hypotenuse, which would be negative 3/5. And I'm going to come in here to all 3 examples and plug in those numbers. So I know that cosine of theta is negative 3/5 squared. Sine of theta is 4/5 squared. Same thing for this version, but now we're only plugging in the cosine of theta. And our last version, plugging in sine of theta. And let's simplify all of these. So 3/5 squared is 9/25. 4/5 squared is 16/25. This is 2 times 9/25 minus 1. And 1 minus 2 times 16/25. If I simplify all of these, I'm going to get negative 7/25. So this is just showing you that yes, there are 3 versions for cosine of 2 theta. You can use any one of them to get to the same answer. There's not really a pro and con of one above the other. So in this case, we're just going to end up by saying cosine of 2 theta equals negative 7/25. Now let's find sine of 2 theta. only one version of this one. We get 2 sine of theta cosine of theta. So I know my sine of theta was 4/5 and my cosine of theta was -3/5. And if I multiply all that together, I get -24/25. So there's my sine of 2 theta. Now, if we remember that cosine is our x value and sine is our y value, we can then put both of these together as a point. So the 2 theta point is going to be at x, which is my cosine, comma, my y, which is my sine. So if I went to -7/25 positive, or sorry, -7/25, -24/25, right there, that would be about where 2 theta goes through. So if I double the angle, that angle is going to go through this point that I listed right here. Now, the reason I'm talking about that is because the last part of this problem says determine which quadrant 2 theta lies in. So if this is the point that 2 theta goes through, then that shows that 2 theta is in quadrant 3. So by finding cosine of 2 theta, which is the x value of 2 theta, and sine of 2 theta, which is the y value of 2 theta, I can put that together to determine 2 theta is going to be in quadrant 3. If I take this theta angle and I double it, it ends in quadrant 3. Let's do one more example for this video, because this one is a little bit stranger. And we're going to do a bunch of examples like this in the next chapter as well. So this is kind of preparing you for that. But here's how I want us to start this one. It says we know that sine of theta equals x. Now that's kind of a weird thing, because usually sine of theta equals a number, and we assign those numbers as opposite over hypotenuse the sides of the triangle and solve for everything else. But in this case, we're saying sine of theta equals x. So here's what I would like you to get used to. Anytime you see a problem where sine of theta, cosine of theta, tangent of theta equals a variable, equals that x, I don't want you to think of it in terms of on our coordinate plane. I want you to just think of regular old SOHCAHTOA. So I am going to make a right triangle, and I'm going to make that theta. Now I'm going to label this right triangle using the information I've been given. So I know that I could put this x over 1. I also know from SOHCAHTOA that this is going to be opposite over hypotenuse. That's what sine always is. So my opposite side is x. My hypotenuse side is 1. Now I can use Pythagorean's theorem to solve for my last side. A squared plus b squared equals c squared. Solve for b. Now notice I did not do plus or minus, because this time, since I'm not on the coordinate grid, I'm on a triangle, I can't have minus. You can't have negative distance on a triangle. You can only have that on a coordinate grid when you have like a negative x or y value. So because we're on the triangle, we don't think of plus or minus for this root. I just have that side. Now that I have that all done, I can label what sine of theta and cosine of theta are going to be. So and ca. So opposite over hypotenuse and adjacent over hypotenuse. So that's my sine theta and my cosine theta. So now that I have all that, let's do sine of 2 theta, which we know to be 2 sine of theta cosine theta. My sine of theta I just found was x. My cosine of theta was square root of 1 minus x squared. And if I put all that together, I get 2x square root of 1 minus x squared, which is my answer. So basically, anytime you have those variables in here, instead of thinking of it on a grid like this, think of it on just a regular triangle and go back to SOHCAHTOA and using your Pythagorean theorem to solve that triangle. So that is all we're going to do for this video. In the next video, we're going to use these double angle identities to do some trig proofs, some verifying of trig identities.